Hello, everyone, and welcome to our next session of the 2024 EA Global Summit. This session here is on the topic of model validation with IncQuery. Before I go ahead and introduce the speakers, I want to call attention to the rest of the agenda for today. There's a lot of fantastic sessions focused on how to extend your Sparks architecture capabilities with add-ins, ecosystem add-ins, either developed by Sparks or developed by partner organizations. So this is a great first presentation kicking that off. And I'd like to introduce our two speakers for today, Dr. Istvan Rath, who is the Managing Director of IncQuery Group, and Chris Armstrong, President, Chief Architect of Armstrong Process Group. A little housekeeping before I hand it over to Chris and Istvan. There will be a live Q&A. So if you have questions, go ahead and put them either in the Slack channel or put them in the the Q&A section within the GoToWebinar platform. Feel free to use the Slack channel during the event. We'll try and address as many questions as we can. If we can't get to them, the speakers will be engaged afterwards to help answer those on Slack. If you're watching this video on YouTube after the event, you can reach out to either of the speakers or to the folks at Spark Services North America, and we'll be happy to get you connected with them so you can get your questions answered. So with that, I am going to hand it over to Chris and Istvan to get the party started.
Thanks, Ryan.
Thank you very much. Okay, question is, how do I share stuff? Oh, okay. Okay, you guys should see. Okay. So, welcome everyone, and thanks again, Ryan, for the kind introduction, and of course for all the attendees for your attention and taking your time to attend our session today. The title of the talk is Model Validation with IncQuery, but we rather like to refer to this the journey to consistency. And in the next about 40 to 45 minutes, you will see what we exactly mean by the journey to consistency and why that matters and why you should be really paying attention to this in your modeling work. So I will start with a very quick introduction on ourselves, and then I will hand it over to Chris for the beginning part of the presentation for today. So, as Ryan said, my name is Istvan Rath. I'm the Managing Director of IncQuery. Many of you may have heard of us in the MBSE space because we attend a lot of the events over the years. We've been around for more than 10 years now. We partner with a lot of organizations, helping them further their MBSE practice and gain success in digital engineering, either when it comes to tailoring solutions or bringing our own products into their tool chain, focusing on quality assurance and tool integration. Floor is yours, Chris.
Oh, you want to flip the slide? So just a little bit about APG. We're here to basically help organizations align their IT and engineering capabilities with business strategy using proven practical processes based on standards. Demonstrate that. We participate pretty actively in a lot of industry standard organizations, particularly at the OMG or Object Management Group. For you millennials out there that might be mistaking what OMG means, where we focus our contribution in formal modeling languages like UML, SysML, and the Unified Architecture Framework. Also have contributed a lot at the Open Group around architecture standards in TOGAF, Archimate, and other standards, as well as being active in COSI around architecture, MBSE, and the object-oriented systems engineering method. So that's enough about us, I think. So we're going to start it off by talking about, kind of the backdrop of, why we feel that this is a worthy topic of discussion and, some of the approaches to solutioning, addressing those through solutions. So starting off kind of, what do you mean by model quality? And we kind of identified three different basic dimensions of that. The idea that a model should be, as to the best of your ability, free from common mistakes, should be conformant with whatever method your organization has adopted, whether that's an enterprise architecture method, software development, systems engineering method, and then of course attempts to try to be as compliant as is pertinent and relevant to whatever standards you're using, whether those be UML, SysML, UAF, Archimate, so on and so forth. So, the challenge is, we want to be able to deliver models as a part of our overall architecture and engineering effort, but we want them to try to be as, consistent as possible across, within a particular project, but also across all projects. And, it's kind of similar to the idea behind, coding standards, where people follow a set of best practices for developing the code, where you can't tell which individual created the code because it all looks the same based on those best practices. So we really want our models to be, independent of the teams and individuals that built them, and want to have that competency and consistency try to be as level across projects as possible. Of course, as everyone knows, errors that we discover earlier in the process, particularly architecture and requirements models that we build early in the life cycle, are much less expensive to address earlier in the life cycle than later when we get into, development and operations. And we also want to make sure that, we've got the ability to ensure completeness of requirements traceability, minimize debugging of models that happen late in the life cycle, particularly if we're going to be using them for simulation or trade studies, and be able to provide teams, with real-time feedback when they're building those models where the gaps are, so that can improve their competency and avoid, making those errors and maturing their individual practice as well as the practice as a whole. So just a couple of examples of what we mean by those three different dimensions. So starting off with, some common mistakes. So I think, go back to the next slide. So here's an example of where we have a real simple activity model. Just FYI, the examples we're going to show here are going to be UML, SysML examples. But the idea, as many people may know that have used the tool, there's a lot of properties of elements and relationships that you can specify that, the tool does not require you to specify, but are often, pretty good ideas. So here's a real simple example where there's an outbound transition from a choice pseudo state that does not have a guard. Of course, one could make the claim, pretty simple diagram, you can probably figure out what's missing, but the idea is that, there's an opportunity to be as explicit and clear as possible. So we just want to make sure that, we've dotted every I and crossed every T. And the challenge, of course, with this is that, visually inspecting these models is, pretty, unsustainable sort of thing. And we also need to keep in mind that, the models that we build, we can't rely on visual inspection of the models. And part of that is related to the fact that not all the information in the model is going to be on diagrams necessarily. So being able to, have a tool that can analyze our models and identify and highlight these types of common mistakes is very helpful. And the next example is standards compliance. And so this is one specific to SysML, which basically we've got an IBD here that's showing parts that have ports, and those ports having item flows between them. And one of the requirements of SysML 1.6 is that if you have what is called a proxy port, they must be typed by an interface block. And just to make it clear in this example, the highlighted port, the little square that's highlighted in red on the boundary of the power system part, is stereotyped as a proxy port, but the item that, or the element that's associated with it as its type, is a power converter, which is not an interface block. It is just a normal block. So, this can, cause us to feel that we're conforming with the SysML language, but we're not doing it exactly. And particularly in a model-based systems engineering and in digital engineering, where we're often going to have a digital thread and a tool chain, There can be upstream and very much certainly downstream consequences of errors like this, where simulations might fail or other downstream tools may report errors. So this can result in, again, rework, missed deadlines, and then unfortunately lead to some overruns. And then the last example is methodology conformance. And so again, remember the idea, make sure we understand that there's a difference between conformance with the modeling language, which at least for the OMG modeling languages, as well as Archimate, for example, they are just specifications for semantics and syntax, but they do not describe how you're supposed to use the modeling language. That is what a method is for. So you might have a method that suggests that every use case must have a refine or trace relationship to a requirement element. And the consequences of that is going to be, scope and context. Namely, if we don't have these traceability relationships, then we're going to be calling into question, why do we have this use case if it's not, contextually related to any of our requirements, which either means we've identified a use case that's not within scope, or we've missed some requirements that need to be added. So we have this missing traceability link. That could, in certain like automotive safety environments, lead to a violation of ISO 26262. That could result in a downstream audit finding during the certification process, which can also result in the same sort of outcome of higher levels of rework and increased budget. So, why, and so where do these things come from? Again, a lack of expertise, a lack of attention, and quote unquote invisible errors. And a big part of the challenge here is particularly with teams that are moving into a formal modeling platform for the first time, are often wrestling with coming to grips with what's the difference between drawing pictures and building a model. And as many of you may know, there is a very fundamental difference, although ironically, the outcome can look very similar, namely a bunch of diagrams with rectangles and lines and whatnot. So as I said earlier, visual inspection of these diagrams is just not a sustainable way to stay on top of these issues. The source of truth is the content that's in the repository, irrespective of whether that is exposed on 0, 1, or many diagrams. And one thing to think about, which is, again, does take some people a little time to come to grips with, is that all diagrams are liars. And what I mean by that is that the information that a particular modeler put on a specific diagram is related to the concerns that that author of the diagram is trying to address. So they may very likely have intentionally omitted information that is not pertinent to addressing a particular stakeholder concern. So when you're in a modeling environment, looking at any particular diagram, you should generally assume there's a lot more to the story, and there's things about some of those elements that are not being shown on this diagram, but possibly are on one or many diagrams. Of course, it's difficult, particularly with, again, more formal languages that have broad coverage like UML and SysML, for any one individual to remember all the rules. And so having some automation to support this inspection is a great way to make sure that people are aware of these rules and are following them, and are, again, making those adjustments in real time, which is contributing to their individual learning. And again, it really frees up, the architects and engineers from being, model managers. There is an important part of, governing the content in your repository and staying on top of it, but being able to offload the major responsibilities of that to a fit for purpose solution to address this really frees up those individuals for doing much more high value add activities. And then lastly, one thing to consider is that the things that are these defects and shortcomings in our models is a way to or we can use the concept of technical debt, which is usually applied to code and the deployed software. But the whole point is that if we don't address these issues, they have a tendency to accumulate. And we end up paying a price for that one way or another, either immediately within the life cycle of the first generation of a product, or perhaps later when we're in operations and maintenance. And again, the whole point of this is that we're not trying to build perfect models. We usually don't get, a bonus or anything like that. Again, the models we're building are supposed to be helpful to, advance the project and reduce risk. So, just like financial debt, technical debt inherently is not universally bad, but we want to be wise about when we choose and make sure we understand it's a deliberate choice when we've acquired this debt in our models. Again, particularly because it has significant downstream effects, such as, again, particularly in architecture models, the changes that were the gaps or inconsistencies affect a lot of different stakeholders, a lot of different subsystems throughout the life cycle. Some of those, the deep ways that the architecture is being implemented are noticed by the users. Unlike code, perhaps, it's difficult to isolate making changes to a model because it's a multi-dimensional thing, and there are, many levels of repercussions and dependencies. And of course, without support, automated discovery can be more difficult. And again, having a small little defect in one place could potentially, have a very consequential effect across those models. So I think with that, Istvan, I kind of hopefully have set the stage for why this is important, and I'll let you, take it away from here to show how IncQuery's got a great solution to this.
Yes, thank you very much, Chris. And in fact, it was a great introduction. And the cue, of course, is from all of this is that we have to automate the whatever practice we choose to do to discover the technical debt that is embedded in our modeling work, and hopefully also automate the way of getting rid of that or reducing that, of course, in a systematic and strategic way. So how we can help with doing that? Well, first of all, I just wanted to also start with a little bit of a context as to actually where exactly this kind of practice comes into play in terms of an MBSE journey. Of course, I want to emphasize at the same time that this technology and tool that we are showing in this session is not specific to MBSE at all. Yet still, of course, it has a lot of motivation from systems engineering in the MBSE community, especially because as an organization embarks on an adoption journey, they often find themselves kind of in between this what we call the silo and the source of truth stage. And the big difference between this is that essentially, when you are really starting to take modeling seriously and not just create models for the purpose of documenting or illustrating something, but also want to take additional value out of those models, such as using them as specifications, generating documentation from them, or executing them, simulating them, or whatever, that's exactly the point where the quality becomes specifically important. So this is why in our so-called adoption journey framework, we put model governance as a key concept towards attaining the source of truth practice. So the technology that we are presenting in today's session is a new tool that we are introducing to the market this year is IncQuery Validator. It's basically a solution that plugs right into Spark Systems Enterprise Architect and augments and complements its existing validation capabilities with a lot of different features and value-added aspects, which I'm going to cover in this presentation today. So essentially, IncQuery Validator is a way to realize an efficient way of implementing the practice of model governance, essentially making sure that your models are consistent in style, understandable across several teams, and of course, free of common mistakes and anti-patterns. So in the simplest term, IncQuery Validator is delivered and used as an add-on to EA. But as you will see later in this session today, it's much more than that. So it can also be run and deployed as a standalone application or as a background service in the context of collaborating teams to generate validation reports and documents and even dashboards that can be of value to various stakeholders in the entire organization. It also comes with powerful facilities for power users. So those of you who want to not just to take advantage of the built-in quality assurance and validation functionality, but also to roll your own. So tailor your own validation logic and build your own validation rules. There is a fully featured auxiliary tool that comes with Validator that can serve this exact scenario. And as I said before, in the team and enterprise versions, the validator can actually be deployed in a collaborative scenario. So essentially attached to the repository, either a SQL server or a Git repository, depending on your choice of deployment. And then the validator can run directly on that repository. So not relying on the standalone environments of the users, but in a separate so-called DevOps or an automation pipeline, which is frequently deployed in a SaaS on an on-prem service infrastructure. And it can then automatically generate and maintain validation reports as you go for the consumption of, let's say, quality assurance experts as part of review or audit or even handover processes in the engineering workflow. So without further ado, let's take a look at the tool itself. So I came prepared with several demos for today, and because I think that demonstrations are obviously always the best way of showcasing the capabilities of this tool. And maybe let's get started straight away with the basic features of this standalone variant. So the one which comes as an enterprise architect add-on, and it plugs right into the enterprise architect environment. So basically, the way you interact with the validator in the simplest form is if you just run it on an open project. As you could see in this demonstration, there is several different so-called built-in validation libraries that come as part of the standard deployment, and you can run any of them on your work, and it will generate some results. In this view, you can see basically a table breakdown of all of the findings that the validator has found in your project. This works very similarly to the built-in capabilities of Enterprise Architect, but it's a lot faster than that, and it's also a lot more comprehensive than that, and it's also a lot more capable in terms of user interaction. So, for example, in this case, you could see that it's very easy to highlight a finding in the project. You just double-click on this row, and it will be highlighted in red, and it will also automatically open the appropriate diagram or the tree view where the problematic element is. And if you want to learn more about what is actually the issue, you can click this open rule description in the right click menu of the finding, and then it will direct you to our knowledge base, which is actually a web-based environment where you can read about the documentation of each of these rules with a little example, what it's looking for, what are the typical problems where it manifests, and what are the recommended solutions for resolving that issue. So it's quite easy to apply this. For example, in this case, we just have to create a new initial state and then connect it appropriately to this one to get rid of this validation problem. And once we have done that, then we just rerun the validator. Now we have the 11 errors, and after running, while the validator is running, you are free to interact with the model, of course. Now you can see that this has vanished, and now just 10 errors remaining in this view. You can switch the errors, warnings, and infos on and off. It's pretty easy to navigate in this view. It makes it very easy to find out what is really the technical depth in the model. We also have a statistics view mode, which kind of presents a little bit different breakdown of the findings. So it orders them by, let's say, the importance or the number of occurrences. So you can focus on the things that have the most let's say, problems in your projects, and then you can just eliminate them one by one. So this is a pretty efficient way of managing and getting rid of that technical debt. And as I mentioned, it's also possible to export these results into a separate standalone document. This is a web-based document, which more or less presents basically the same information. So a high-level overview of the let's say, the quality of the project, as well as a detailed breakdown of all of the findings that the validator has found in your project. This document is also dynamic, so it's possible to navigate back to Enterprise Architect using these special links. So it works exactly the same way. It opens up the appropriate project and the appropriate location just from a single click from the browser. It's also possible to serialize this report in a technical format, either in a JSON serialization or a CSV or Excel file, so you can process the results further. This is just an illustration how this JSON looks like. It's pretty much a feature complete representation of all of the validation or quality related metadata that the validator is generating. So for advanced users, and of course also for the team and enterprise tiers or for the validator itself, this is a pretty powerful feature because it allows you to capture and further process the quality related findings in such a validation report programmatically if that is what you are looking for. So this was the standalone basic feature set of the validator. And now let's go a little bit further. So basically, in terms of validation functionality, there are two main kinds of, let's say, rules that the validator supports. At the fundamental level, the validator does what we call so-called structural validation, which is essentially checking whether the work, the model that you have created is a proper instantiation or usage of the MDG schema definition that your project is referring to. Essentially, these kinds of violations are possible to create because a large portion of users are not really using what is called the strict mode in Enterprise Architect, or the strict connector syntax mode. Or you may have used a previous version of a schema in a legacy project, and you open that in Enterprise Architect in a newer version, then you can get similar issues. And by default, these are really hard to discover, but they are a significant source of what we call standard compliance violations. So the validator at the fundamental level does such an MDG validation. It will show you all of the different locations where you have a problem, either with the typing across relationships, or you have some element in a diagram that is not supposed to be there according to the MDG. This is called the view specification, or some similar issues. And this works with any MDG, so both built-in ones, encrypted ones, and of course also your own ones, because it's a generic functionality. So this is again just a simple demo sequence showcasing how this works in the context of BPMN. This is a pizza delivery process captured in the BPMN format. And here you can see that there are actually several findings of all three types, so both relationship, source, and target. Basically, there is a missing stereotype here, which is really hard to spot by default. So that's why the validator can come really helpful to identify such problems and also to get rid of them easily. In this case, I think what we will do in this demo sequence is just to delete the problematic relationships. This realization is not allowed in terms of the BPMN standard. So that's why a simple fix is just to get rid of the problematic ones. And once the deletion has happened and we rerun the validation, then the violations will go away. So moving on, the second major kind of validation is what is very often called semantic validation. There is a nice knowledge base article on the Sparks community site that explains what semantic validation is, also in the BPMN context. So that's the reason why we are using this in this session. Basically, in this particular case, in this article, the semantic validation rule is that final nodes should have incoming edges and not outgoing edges. And basically, this is something that is allowed in terms of the structural rules, so the MDG, but it doesn't make sense from a human or an intelligent human point of view. So this is basically the main point of semantic correctness. So these semantic correctness rules are actually captured as domain-specific rules, so rule set rules in IncQuery Validator. And as you have seen in the previous demos, we ship a lot of these semantic validation rules arranged in various rule sets by default, but you can also create your own. So using this rule set SDK, this is actually a small screenshot from that environment. It's possible to write your own rules in a specific language, in an open source query language called vQuel. And once you do that, you can very easily deploy such semantic validation rules into the validator and then run them. So we did this exactly with this example in this particular sequence for this final role, and it pinpoints exactly the source of the problem. So if you delete that and create it in the proper direction the other way and rerun the validator, then of course it will show that everything is correct. So this is a very, very simple example of how semantic validation rule works. And as I had shown you before, all of those rule sets like sysmod or the SAIC are built using this technology, but of course for many, many different rules. For example, the SAIC rule set contains over 200 rules that all of which represent some best practice in the systems engineering domain. So as I mentioned, the validator is not just an add-on to Enterprise Architect, but it also can be deployed as part of a collaborative engineering environment. And in this case, of course, the main benefit or main point of validation is that governance or governance specific policies can be applied in a consistent way across several different people. So independently of whether they individually use the validator or not, if they are collaborating over the same set of projects, let's say over a Git repository or a SQL repository, and maybe using Lemon Tree for that, which was covered in one of the previous sessions. Here, you can also deploy the validator as part of what we call a governance automation pipeline setup. And in this case, the validator will run as a standalone service on the backend, let's say, automatically. It will attach itself to the repository, so it will read data from the SQL server or the Git repository. It will run the same validation logic over that and generate these HTML reports or JSON or CSV reports automatically, which can also then be plugged into a dashboard environment that allows you to observe how certain quality related metrics or tech debt related metrics evolve as we go forward in the project and create new revisions and so on and so forth. This is a very powerful feature in the right hand. So quality assurance people, especially the ones who are part of regular review and audit processes, will find such a functionality very, very useful. So let's see again through an example how that works in real life. This is an instance of Jenkins. It's a very popular DevOps environment. It's used in a lot of companies, and it's very easy to plug the validator into Jenkins because we offer a lot of templates and configuration files that make it very easy to set this up. In the Jenkins environment, the validator generates a so-called validation artifact, which is a zip file. And this zip file can actually be directly imported by the standalone edition. So you don't need to run the validator again and again. You can just import the results from the Jenkins environment and use it the same way as you would with any other, as you would do with the regular standalone workflow. But in this case, what typically happens is that after such a finding has been fixed, the engineer actually commits the fixed state back to the collaborative repository for the validator to kick in again and run again. So this is all automated because after the fix has been committed, which is what you can see right now in the demo, the validator will then run on the server automatically in the background, and it will produce an updated version of the report. So a new report will be generated. And the data that is coming from this new report, this metadata, will then update the dashboard. So you will see in the trend visualization that we actually made an improvement, and now there is one less problem in the model. And this is basically what a quality assurance expert would be looking at in a real world workflow when we are close to a new revision or a release or a baseline, because this is basically the fundamental indicator that things are going in the good direction in terms of quality and technical depth, so to speak. So let's take this one step further. And if you are using an even more sophisticated collaboration platform, like the GitHub platform, which is a pretty popular way of collaborating over software, and of course it's possible to use it for collaborating over enterprise architect models as well. For example, with the aforementioned Lemon Tree solution, then the validator can be an even more powerful ally in your workflow, because it can be used to define and execute what we call quality gates. So these are essentially components in the collaborative workflow, which actually realize a kind of an automated approach to model governance. And what a quality gate does is it basically automatically checks if, let's say, a proposed change or a proposed fix to a problem is actually resolving that issue. So the quality gate checks whether the work that has been proposed for a merge operation in terms of the Git style collaboration passes appropriate checks and is ready to merge. And this way, you don't even need a human quality assurance expert that much anymore, because a lot of the groundwork can be done fully automatically as part of the collaboration platform. So let's take a look at how this works in real life, because that's, again, a lot easier to understand than just by looking at a figure. So here we have GitHub. We have the 0.2 release of our project, and here our engineer realizes that the error has slipped into this release, because the built-in validator report indicates that there is an error in this release. So what our engineer does then in true Git style fashion is to create an issue to say that this error needs to go away. We need to fix this error because there is a problem. It cannot be released like this to downstream stakeholders. So in terms of Git, what we typically do is, once such an issue has been created, is that we create a so-called branch for this issue, which branch will be then used to actually do the real work itself. So the change will be then done on that branch. It's very easy to create such a branch using the web-based interface that has just happened. And once that's done, you can very easily synchronize with that in your local Git client, in the GitHub client in this case, and then switch over to that branch. And once we have done that, then we can just use Enterprise Architect to open the file. We are now on the fix branch. And what we do is, again, we rely on the automatically generated report to identify where this error is. So you can just download the HTML file. And this HTML file can also be imported into the validator directly. So no need to run anything locally, just import stuff. There you go. You can then double click, navigate to the appropriate location. Here, there are several different diagrams on which this particular problem manifests. So we just pick this one. And here, the issue is actually that this actor is not part of the system context. So there is a special kind of a composition relation missing. Once we do this and add this to the model, that's basically the fix. It's a very simple one. We again use Lemon Tree to commit and push this fix back to the repository on the feature branch still. We just add the comment signaling that this is what we have done. And now is when you should really pay attention, because the magic will happen. So once the commit is done, then this automation will kick in, but this time not on Jenkins, but on what we call the GitHub automation platform. So we can see that the commit has been pushed to the repository. And in order to really trigger this automation, what we have to do is to create a so-called pull request on GitHub. So this will be an artifact that will tell the system that we are ready to ask it to actually analyze our work and make it ready for merging. And as you can see, the automation has already kicked in. This is where the model validation is here running. And what is now happening in the background on the GitHub infrastructure is that a new validation report is being created. And as you can see, that error is now gone. So we only have just 2 warnings, which means that the quality gate has deemed our work worthy of merging. So it passed, and therefore it can be merged. And merging is just a click of a button. Again, on GitHub, it's very easy to do. So now our work is merged to the main branch, and therefore we can create a new release. Let's call it 0.2.1. This will be a bug fix release based on this 0.2.0. GitHub can now automatically generate some release notes based on what we have done, and what we have changed is pretty smart. And then we just publish the release with our contribution. Now, one last thing remains to be done is basically an execution of what we call the release quality gate. So again, the validator will check our published release, basically exactly via the same mechanism. So the quality gate will be executed in the GitHub infrastructure in the background on the server. The user doesn't need to do anything at all. Just wait a little bit until our job will be queued and then executed, and then the results will be published automatically to the system. It is a little bit accelerated in time so that it doesn't take so much from our demo session today. And you can see that in the release notes, this report has also been automatically published. So this is basically a realization of a fully automated approach towards model governance. Now, just to round this off, finally, what I would like to show you is just a glimpse of what is possible with all of this validation and quality related metadata that the validator automatically generates after each of its runs. So as you remember, architecturally, the validator is capable of running on many different projects stored in either in a SQL server or a Git repository. And it can store the validation related metadata, not just in these JSON and CSV files, but also in various kinds of database backends. And you can use advanced analytics platform like Tableau or Jupyter or Power BI or some others for the purpose of analyzing this data and making interesting insights on top of this data. And in fact, we actually deliver as part of the enterprise tier of the product, several templates that can be used as a starting point for building what we call an enterprise-grade quality dashboard. And this is what I would like to show how it looks like in practice. Now, in order to make sense of what you're going to see, what we need to clarify a little bit is really what are the metrics of quality that we are analyzing here. And essentially, for this, there are several fundamental concepts that needs to be understood a little bit. So first of all, for each of the validation rules, what the validator calculates is not just the findings, so all of the instances where there is a problem, but it also calculates the so-called applicability scope of the rule, which is essentially the number or the whole set of overall context or elements in your model in which the rule could have a potential application. This will be very relevant in terms of calculating the so-called normalized error percentage, which is a model size independent relative metric. It's a percentage metric between 0 and 100% that really corresponds to what kind of or what severity of an issue you have in your project. If it's 0, then basically all of your potential elements are error-free. And if it's 100%, then all of your potential elements have an error, which is, of course, very bad. In addition to that, the validator also gives you the ability to assign another metric to each of the rules, which we call the technical depth. This is in its simplified form a property value that represents an expert's assessment of the effort that is required to fix one finding of a given rule in terms of person minutes or something like that. And based on a combination of this normalized error percentage and this rule-specific technical depth, we can actually calculate a so-called quality score. This is actually this A to E value that you may have seen in the reports which I have been showing so far. And that's basically a very high-level overall indicator of project health. If you have no violations, you get an A. If you have any fatal violation, you get an E. And you get something in between, depending on this normalized error percentage and this technical depth in your model. So these are the fundamental metrics that we can calculate. And in Power BI, it's very easy to put together what we call an overview dashboard that basically represents a high-level glimpse into what is the health in your, let's say, workspace or set of projects. You get information basically on the projects and their sizes and the revisions, the number of findings that the validator has found in the last execution, this normalized error percentage, the overall technical depth here already in the magnitude of man days, as you can see. So this is really adds up in real world project to a substantial amount that needs to be addressed. And of course, the quality score of the project. And what this is then useful for? Well, for example, you can take advantage of the fact that the validator runs a lot, especially in the collaborative scenario. Maybe if you have been running it for many revisions over several months or even years, like this in this scenario, and then you can observe how quality evolves, or this quality related metrics evolve in terms of revisions and time. For example, how technical depth is aggregated or reduced, hopefully, and how maybe the normalized error percentage can represent this relative quality metric of your work. Now, the Power BI also gives us the ability to create so-called heat maps, which can be very useful to identify where the dominant majority of our technical depth is coming from. For example, in terms of validation rules, these are all validation rule names that give a hint to a quality assurance specialist, what needs to be take a look at, what needs to be prioritized in terms of addressing and fixing first. So this is a very powerful tool once you have this technical depth in your project, and if you want to get rid of it, what would be a good strategy to choose as a first target of your work. Finally, since we have version data as well, it is possible to trace the technical depth or the introduction of the technical depth back to the individual contributor or committer level, because, for example, Git has the ability of capturing this information. So based on that, we can create what is called a blame chart, which is essentially also a kind of a representation of the technical depth, or the source of the technical depth, where the technical depth is coming from, but this time in terms of people and not rules. And this may, of course, give some suggestion to a manager or a leader as to whose work should be reviewed perhaps a little bit more thoroughly than the default situation. So to sum up, the IncQuery Validator comes in 3 tiers: the standalone tier, the team tier, and the enterprise tier. The standalone is an enterprise architect add-on that provides very fast validation capabilities for actually also the most recent versions of enterprise architect. The team tier takes this to the next level by offering a standalone complementary application that can be deployed in this DevOps style automation pipeline. And finally, in the enterprise tier, you can scale this to a large organization and, of course, take advantage of these analytics capabilities to build pretty advanced dashboards. Chris, I hand it back to you.
All right, so we just got literally a minute left. So, and again, thanks, Istvan, for covering a lot of territory. We do have some joint webinars that we did over the course of the summer to dive into some of these topics in a little bit more detail. But hopefully we've made, demonstrated that, if you believe that consistency of models is important, that there is a solution to this. Again, visual inspection is just tough to sustain. The complexity of our repositories, the languages that we're using, the methods that we're following make it pretty tough for any one person to keep all of that in one place. And being able to help people understand what these shortcomings are in real time, so that the architects and engineers can really focus on those critical value add activities, I think is a really big important outcome of the approach that we've described here. So I think with that, Ryan, we're pretty much out of time, over a couple seconds. Don't know if we have any time for questions now, but if not, we can do it after the fact in Slack.
Yeah, Chris, thank you. We are out of time, unable to take any live questions. If you could go ahead, that would be great. And I'd like to thank Istvan for presenting the content. Session recordings will be posted on the EA Global Summit website and on the portal. And if you'd like to arrange a call with Chris and or Istvan, reach out to your Sparks account team or email sales@systems.us, and we're happy to set that up for you. 2 minutes with Steve Householder, the Sparks, Confluence, SharePoint, Teams integration. Go ahead and check your registration emails on that. And again, thank you for joining this session.